I'm about to blow your mind with the lowest distortion, lowest noise floor amplifier that we've ever tested in a 23 plus year history at Audioholics. It's from a company called NAD. That's what we're going to be talking about in today's video. Hey folks, I'm Gene Delasello with Audioholics. So I'm very excited to bring you this test report of the NAD M23 2-channel Class D amplifier. The retail on it is $37.49, and it's in a very compact, very high efficiency, high quality looking chassis. As you can see right here, beautiful brushed aluminum. The interiors are just incredibly laid out here. And the back panel, which I'll get more into in this video. Now, this is not a listening test. This is a measurement report. I will be doing a listening test in a separate video. So I don't want to see comments down below saying, well, what did it sound like? If it measured great, what did it sound like? You're going to be hearing about that in a second video. So what I want to do now is I want to share my screen with you so I could go over this test report. It's on the Audioholics website. I'll put a link in the video description below. But I think it's important to kind of explain all the stuff that's in this review. And I want to start out just showing you some of the specs on this amplifier. So it's rated at 200 watts a channel at 8 ohms, 380 watts at 4 ohms, and it's bridgeable to 700 watts at 8 ohms. And the signal to noise ratio is 101.7 dB at 1 watt. That's incredibly low noise. And I'm going to show you that if we met that or if we exceeded it or not. That's what's really going to be impressive. And this is just, very good specs here on an amplifier that you would expect from an amplifier of this price, but not in this weight class. We're talking about an amplifier that weighs, under 30 pounds, basically 21 pounds or so. So this is something you could easily pick up with two hands, move it around, put it in a rack, put it on top of a rack, not worrying about breaking your back. So what makes this amplifier so light, what makes it so efficient, what makes it so special is its Class D amplifier module. With very high efficiency, you get over 90%, about 95% at full load. So very high efficiency as opposed to linear amps, which at best are 60, maybe 65, 70% at full load, and much lower efficiency at lower power levels. That's why you need big heat sinks on linear amplifiers when they have a lot of power output. Don't need that as much with this because it's so much more efficient. And what makes this amplifier so unique is it's got the Purify module from Bruno Putzis is the designer. It's the 1ET400A. And Bruno is a friend of the channel. He's done some articles in the past for us. And he also did a video on negative feedback and why you need negative feedback. And I'll link it in the video description below. I know there's some audiophiles that don't understand feedback in amplifiers and why it's so important. But the crux of why this amplifier is so good is because the feedback and control mechanisms in it are that good. They're that incredible. There's a lot of feedback that's applied in this amplifier across the entire audio band. And the switching frequency is much higher up at 550 kilohertz. So it's way past the audio band. So that means it's not going to interact with the load because of the output filter. And your frequency response is going to be very consistent, as you will see in our measurements. So I actually measured this amplifier twice. I had two separate samples. The first time I measured this amplifier, I was not getting the distortion levels that NAD or Purify were claiming. And my distortion was really low. I mean, it was still among the best amplifiers I ever measured, but I couldn't get it to the levels that these guys were specifying. We're talking about like 0.00017%. Very hard to measure that accurately. And it turned out it was my test fixture, because I have these alligator clips, as you can see in this picture, on my test leads. And these actually have some inductance in them because they're magnetic. And these little alligator clips were raising the distortion, raising the noise of my measurement, and I couldn't get accurate enough measurements. So when I cut those off and I just use really short leads like you see here, the first time I tested the original sample, somehow the amplifier blew up, a capacitor inside blew up. Not sure what that failure mechanism was. I sent the unit back to NAD. They're still looking at it. It's very shocking that this would happen, because I know this amplifier is designed for short circuit to handle it. It must have been some weird gremlin that I had in my setup that caused it, because the second sample they sent me, I spent several weeks testing it, torture testing it, running it right to, its max output and beyond, and I never had the thing blow up or anything. I mean, maybe at best I initiated the short circuit protection on the amplifier and it just shut off. So I don't know why the first unit failed, but I can tell you the second unit has been 100% reliable since I've gotten it and tested it, and I've been using it. So I talk about just the incredible performance that you can get out of an amplifier like this, and how you must really take great care in doing these measurements. And that's what I did. I wanted to make sure, so I had NAD send me their full measurement report of this amplifier, and I was able to go in there and basically look at every one of their specs and replicate it, and it's in this test report. And you can see, again, this is just an incredibly well laid out Class D amplifier. You could see that the amp module is towards the back of the unit, directly coupled to those connectors in its own kind of area away from the power supply, which has its own daughter board here in the front. And the capacitors are, again, away from the heat areas. Just well done. Really thick cables twisted when you needed them. There's no bus bars carrying the current through this amplifier, which is a good thing. So I measured the gain of the amplifier, and there's 3 different gain settings, and this is part of what NAD does. In fact, I want to also mention that NAD, even though it's a purified module, they actually build the module themselves. They follow the reference design of Purify, but they build it because they have a preamp gain stage that they want to balance and match to, and their own power supply, because the Purify doesn't have its own power supply. So NAD designed the SMPS from the ground up on this amplifier, and that takes some doing. It's really hard to design a good SMPS that's clean, quiet, and reliable. And that was kind of their bench. Their goal on this was to get all 3 of those into a design like this, and to be efficient, because now you have a regulated supply that's going to supply much more stable current to the amplifier, and again, lower the distortion. So here's the frequency response, and this is under various load conditions. This is at no load, this is at 8 ohms, and this is at 4 ohms. And you can see there's no difference at all in the frequency response. Not even all linear amplifiers behave this well. I mean, this has kind of been the staple of linear amps being better than Class D for over a couple of decades, because most Class D amplifiers, they were very load dependent. This Purify module is completely load invariant. It means it does not change the frequency response at all, regardless of the load it drives, which means this amplifier will sound consistent no matter what you throw at it. So you don't have to match this amplifier to a certain speaker, because this amplifier is always going to perform the same, regardless of the speaker load that it drives. That's quite a remarkable achievement, as you can see here. The bandwidth is at this up to 65 kilohertz. It's just textbook good design right there. Incredible. And here's what really blew my mind is this FFT. So when I ran a 1 kilohertz FFT at 1 watt, I couldn't even measure the distortion spectra. It's down in the mud, as you could see with my test gear. It's down, to the noise floor of my unit. There's just no harmonics. Usually you would see some harmonics, second or third order harmonics, maybe 100 dB below. This is below that. This is just immeasurable with my test gear. And that's the other thing I wanted to mention is the distortion spec on this amp is so good that it, in some aspects, it exceeds the performance of my audio precision. So not all of my measurements can be as precise as I'd like them, but because I have an 8-channel HDMI analyzer, there's a performance hit on my test gear because it does 8 channels. So if you really want to get every little detail, a 2-channel audio precision is the way you can measure that, in which NAD actually uses when they develop this amp. So here is something that's very unusual. When you test an amplifier at full power, this FFT generally gets nasty when you get to rated power. If you look at that one example in the last video I did with the Past Labs amp, I think the third order harmonic was like 50 or 60 dB below the fundamental. Was not a good result at full power. This is at full rated power, 200 watts, and the third order harmonic is 113 dB below the fundamental. That's just unheard of. I mean, we're at basically at the drive level or at the distortion spec of my audio precision, and this is at full rated power. So I can't believe that. And if you look at the even at the low frequencies, there's no DC offset. There's really no ground issues. It's just a really quiet, really clean measurement. I mean, this is a kind of measurement you would expect at 1 watt, not at full rated 200 watts. So kudos right there. That's an incredible achievement again. Now we're looking at frequency response versus distortion. And I wanted to show it not just at 1 kilohertz, but the full bandwidth. So I ran an AES 17 filter at 20 kilohertz. That's why the sampling, you only see it down the distortion to 10 kilohertz. And you can see here, I did it at 1 watt and full power. And look, the distortion barely rises at full power. We're still at 0.00005%. Just super low distortion. I just don't see this kind of performance, generally speaking, in even the best linear AB designs. And now if you want to see what this amp does out to 20 kilohertz, you have to use a two-tone test, which I actually reprinted what Purifi did, and I spot checked it, and I got the same thing. And you could see the distortion spectra below those two tones is incredibly low, 120 dB or more. It's just, this is just stuff that if you're an engineer and you look at this, and it's an engineering marvel. I mean, when I was in my days of telecom, this is the kind of distortion levels we needed for really small signaling. And it was unheard of to have any audio equipment have this kind of distortion spectra, especially when you're dealing with equipment that's producing power. So very incredible achievement. Next, I want to go over the signal to noise ratio. Again, this is at 1 watt A weighted. I typically, when I measure at 1 watt, I see anywhere from 80 to 90 dB in most amplifiers. 80 is a good measurement. 90 is a really good measurement, really quiet. It's 103 dB, basically, 102.7. And this is even better than what NAD spec'd. I got about 1 dB better signal to noise ratio than NAD spec'd. I've just never measured an amplifier at 1 watt that had that kind of low noise. What this means is you could take any speaker, whether it's a super high efficiency Klipsch or any other horn loaded speaker, compression driven speaker that has 90 to 100 dB of sensitivity or more, and you're not going to hear hissing coming out of the amp because this thing is so quiet. So that's quite incredible. And then I measured it at full rated power, and I got what I expected at 126, 127 dB. The last thing over here before we get into the power measurements is I measured crosstalk. So that's taking a signal and injecting it in one channel and then measuring how much of that signal gets into the unused channel. And I did it at 1 watt and full rated power. And you can see the separation here is excellent at greater than 84 dB at 20 kilohertz and 100 dB at 1 watt. So this is like, it's basically giving you very good isolation as if it's a monoblock, like you have two separate amplifiers, which means you got to get really good stereo imaging. That's a good indication right there. I like to see at least 60, 70 dB at 20 kilohertz, and we're well above that here in terms of isolation. So kudos there. So then I measure power. I measure it continuously, and then I measure it with sweep tests, and then I do some burst tests. And basically, I wanted to see if this thing would do what NAD was claiming. I ran it at 200 watts a channel, both channels driven at 8 ohms. And you can see the frequency response here is very stable, very clean. This is below 0.1%, 0.01% THD. So well under the distortion spec at rated power. Then I did a power sweep versus distortion. And this is pretty cool. I actually put the SINAD results at the top on the right vertical axis, and then the THD percentage on the left vertical axis. They're the same thing. It's just one's represented in percentage, the other one's represented in dB. There's nothing magical about it, but it became popular in ASR, so I included for you guys. And you can see here we go at 0.1%. We've got 240 watts a channel, both channels driven, and 8 ohms. And at 1%, it's 259 watts a channel with both channels driven at 8 ohms. That's good because it's well above the spec. And for you SINAD aficionados, that's 110 dB SINAD. I mean, that's just incredible amplifier results. I think there's maybe 1 or 2 other amplifiers on the market that I could think of that can do that. And that's just really an incredible achievement for them. So now we did the same test at 4 ohms, and we got more than rated power because they rated it, I think, at 380 watts with both channels driven at 4 ohms. And I got 444 watts at 0.1%, 529 watts at 1%. This thing's a powerhouse. I mean, it does 4 ohms really well. And the SINAD is still high. It's still over 110 dB. So the distortion, as you can see, is 0.0005% at 380 watts. That's pretty awesome. I mean, this amplifier is not only meeting power requirements or power spec, it's exceeding it. And that's kind of what NAD always does, right? When NAD tells you an amplifier is 100 watts a channel, they give you 100, 120 watts a channel. They always over deliver, and they tell you all channels driven. They don't play this game where they're giving you one channel driven at 10% distortion at 6 ohms on Tuesday if you turn it upside down. No, they're giving you the actual real bench test results, both channels driven. So that's quite impressive. So now they do have a bridge mode, and I do not recommend using this amplifier for that. I know people are going to say you're crazy. This is a feature. Yeah, it is a feature. And if you have speakers that are above 5 ohms nominal impedance, I'd say, and if you have the money to buy 2 of them, knock yourself out, do it in bridge mode. But I think there's better, more economical options if you need more power than what this thing does, not bridging it. But you could see when I do bridge the amplifier, I get incredible amounts of power. You get 900 watts at 0.1%, a kilowatt at 1%. But the SINAD starts dropping pretty significantly from over 100 dB down to, 85 dB. Now, let me make this clear. That's a freaking good number, regardless. It's not state of the art like when the amplifier is not bridged, but that's better than most linear amplifiers at full power anyway. But I still am cautious about recommending bridging an amplifier like this. I just think this is really meant to be a 2-channel amp. And part of that is you can't really run this thing at 4 ohms bridged. It does not like it. If I ran it for any continuous amount of time at bridged at 4 ohms, it would shut the thing off with full loaded test signals. You can see the SINAD drops down to 70 dB, and you don't really get much more power. You still get a kilowatt. It's because the power supply just can't deliver the current in order to get double the power when you have the load impedance. This thing can't just can't do more than 1100 watts, which is an incredible achievement on its own. But like I said, this amplifier is really not meant to be bridged. And I talk about, even though in the app note there is a bridge option for Purify, but you got to change the whole feedback loop in order to optimize the distortion. And NAD, I understand their argument that they weren't going to go and optimize the feedback loop for a case that very few people are going to use, and that it would complicate the design and potentially make the distortion or noise worse for when you're not in bridged mode. And I have a whole explanation of that here. I don't want to rehash this whole thing, but you guys are welcome to read it. And then I have the dynamic power. This is a CEA 2010 burst. And the funny thing about this is you don't get a lot of dynamic power when you have an amplifier that's a Class D, especially with it SMPS, because you're getting most of the power it's capable of doing continuously anyways, and short, like with the sweep tests. It's just these SMPSs don't have the headroom that a linear power supply does. But look at the power you're getting. I mean, continuously, we're still getting incredible amounts of power. This is one of the few exceptions where the dynamic power is equal to the sweep power or the continuous power. So you could see here, I basically outlined all the different power tests that we did. 2 channels, 1 kilohertz, 444 watts at 0.1%. That's the sweep versus 460 dynamic power. There's just not a lot more available than what you're seeing here with 2 channels driven. Don't forget, we're dealing with 460 watts times 2. That's over 1,000 watts of power. So this power supply is capable for a little over 1,000 watts, and that's all you're getting out of it, which is to say a lot of power and probably good enough for most people's needs. The only other thing I'll say about the bridge thing is because of the way this thing is laid out, if you do bridge this amplifier, you've got 8 inches of space between the plus and minus terminals of the speaker outputs. And if you're running some fancy cables, I don't know of any fancy cables that you can separate the connectors that far apart. And if you can separate them that far apart, I hope you're not doing that for the entire length of the cable, because you're going to increase your inductance. You want to keep your leads as close together as you can. And you definitely have a challenge here with this 8-inch gap between the plus and minus. So my recommendations on that is don't bridge the amplifier. Use it in 2-channel mode like it's really meant to. Last thing I want to talk about is it has a little capacitive touch here to turn it on and off. got some magnetic feet you put on the bottom. It's just a cool looking amp. And I would tell you, if you're using this amplifier with like an AV receiver, like I'm going to be doing with the Marantz SR8015 to power my Perlison R7T tower, S7T towers, I'm sorry. I'm going to use the medium gain setting. There is a little bit of a noise penalty when you increase the gain, but it's so low noise, it really doesn't matter. And I figured using the medium gain setting would allow this amplifier to reach maximum power at a little over 2 volts, which most preamps on good AV receivers can do. The Marantz actually can do 4 volts RMS. But if you're using it in a dedicated 2-channel scenario with all your XLRs and you've got a really good quality preamp, you could use the low or medium setting. I don't see the reason to use the high setting unless you're using some type of really crappy receiver that only puts out a volt RMS. And at that point, you defeat the purpose of an amplifier that's this good. You don't want to match this with a preamp that's noisy or has a lot of distortion, because then you just mask how good of an amplifier this really is. So guys, I hope you found this video useful. If you're an M23 owner, give me some comments down below. Like I said, I'm going to be doing a listening test, and I'll do a separate video on that. But as it stands right now, this amplifier holds the record on Audioholics as having the lowest noise, lowest distortion, best bandwidth uniformity under any kind of load condition that I've seen in any Class D amplifier to date. There's just so much to like about this. And the fact that this amplifier can fit literally in 2 hands and you can move it around the house is a godsend to me with someone with back issues. But it's also the future of amplification, because when you're dealing with Atmos systems and high channel count systems, you can't be packing, 16, 20, 32 channels into a couple of chassis with a linear AB design, because it's just going to generate so much heat and waste so much space. So you can have an amplifier like this. I know NAD makes an 8-channel version as well. And just imagine the future of where we're at when you start getting 16-channel amplifiers with this kind of module, get this kind of performance and efficiency. It's awesome. So we're living in a golden renaissance, I think, in Class D, as well as just modern DSP and what we can do with our systems. Give me some comments what you think about that down below. Have you heard this amplifier? Is this something you plan on buying? And if you do buy it, we do have affiliate links to Audio Advice. They're our channel partner. We appreciate that. Don't forget about our Patreon channel at patreon.com/audioholics. We appreciate your support. You get direct access to me if you want to suggest video topics or ask questions. And until next time, my friends, keep listening.